Today we get to dig deeper into operations with surds. This is Kisembo Academy and thanks for tuning in. But before we get deeper into operation with surds, we need to distinguish between what we mean by like surds and unlike surds. Now when we were doing algebra, this is like saying like terms and unlike terms. So also here we have what we call like surds and unlike surds. And here we distinguish them from what we call the radicand. The radicand is this, the number we leave in the surd form in our simplification of surds. So here, these radicands, when they are the same, when you're having surds that are having the same radicand, these qualify to be called like surds. It's like in algebra when you're having x, then 2x, then 4x, then 9x. Because they're having the same unknown, they qualify to be called like terms. Now, of course, the unlike surds is the opposite of like surds. For unlike surds, they are simply numbers, or they are surds that are not having the same radicand. And if you can see here, this is having root 2, root 7, root 11, root y. So these are unlike terms, these are like terms. Now when we are adding and subtracting surds, we are going to make our additions and subtractions based on this radicand. Of course, before you add any two surds, they must be like terms. An illustration on how we add and subtract surds. In our first number, we have 2 root 6 plus 6 root 6. And we are saying we use the distributive property. We are having root 6 as the common term here, which is the like term. We put it outside the brackets. And in the brackets, we are having 2 plus 6. And that's how we are ending up with 8 root of 6. Likewise here, we are having root 3 as the radicand. So we put this root 3 outside the brackets. And we are having negative 4, which is right there, and 5. It's more like factorizing up. And of course, negative 4 plus 5, you're getting negative 1 root 3. Now, when we are adding surds, if it were algebra, this root 6 is more like x. 2 root 6 is like 2x plus 6x is going to give you 8x. Negative 4x plus 5x is going to give you negative 1x. As simple as that. So you can as well treat them like in that kind of algebraic way of looking at it. But when we are dealing with surds, we can only add and subtract surds that are like. And we say that like surds are surds that are having the same radicand. If you look at this, we are being required to simplify this. Now, this is a mixture of surds that are both like and unlike, as well as whole numbers as well. So what we do is that here in our first step, we collect like terms. We have 5, which is that one 5. 5 minus 4, so which is that one minus 4. Then we look at numbers with root 3 and we put them together. So we have plus 2 root 3, which is that one. Then plus 1 root 3, which is that one. Then we have numbers that are having root 5. Then we have plus 3 root 5, which is that one. Then minus 20 root 5, which is that one. Right there. So after arranging them like that, collecting like terms together, then you go ahead and simplify them. 5 minus 4 is 1. Then we have 2 root 3 plus 1 root 3 giving us 3 root 3. This is like saying 2x plus 1x, giving you 3 root 3x. So we have this also, the ones with root 5 and root 5. So this is like saying plus 3y minus 20y. Of course, plus 3y minus 20y, it's going to give us positive 3 minus 20 is going to give us 17. Minus 17 times the square root of 5. And definitely we can't solve this any further than this, and that gives us our answer. Now another person would do it like this. From this step, would come and do it like this. This is 5 minus 1, which is 1. Plus, now we have root 3 here, we have root 3 here. So he says plus 2 plus 1 in brackets root 3. Leaves root 3 outside the brackets. Then he comes to this. It becomes plus, in brackets he puts it's 3 minus 20. 3 minus 20. And he puts the root 5 outside the bracket. And of course you get the same answer. It will become 1. You'd still get the same answer. So we'll go ahead and evaluate them. So in numbers like these, we are supposed to first of all, the surds we are supposed to deal with are supposed to be simplified to their simplest form. If you look at 125 here, it is the same as saying 25 times 5. So this is 2 root 5, it's going to be 2 root 5 minus, under this square root, we can simplify this surd. It needs to be in the list. So this is going to be 25 times 5, then plus 180, that is, can be simplified further. And of course 180 is the same as 36 times 5. So this is going to be 2 times the square root of 5 minus root of 25 times root of, this is the same as root of 25 times the square root of 5 plus, this is going to become the root of 36 times the root of 5. Now you notice that in these factors here, the factors we chose to simplify this 125, this was 25 times 5, the factors we used to expand this number is 36 times 5. We chose on these ones because if you look, 25 is a perfect square, 36 is a perfect square. That is why we chose them. So when we are simplifying these surds, just like before, we are supposed to make sure that we choose two numbers of which one of them should be a perfect square, because from a perfect square you can easily find the square root of a number that is a perfect square. So right here, this is going to become 2 times root of 5 minus square root of 25. 25 is a perfect square, so square root of 25 is 5 times root 5. Then this is going to become plus 36. The square root of 36 is 6 times root 5, which is that. So we end up with a statement that we are having 5 like terms, root 5, root 5, root 5. So what we do here is simply add. It's because all these are like terms. So it's going to become 2 minus 5, which is going to give us negative 3. Negative 3 plus 6 giving us positive 3. So it's going to give us 3 root 5. So this as well, to simplify this surd, first of all, again, our first step is to make sure that the surds we are dealing with are in their simplest form. So if you look at this, 80b can be simplified further, simplifying this surd. Likewise, 20a squared b can also be simplified further. So that's what we begin with. So this is going to become 4a into, now 80b is the same as 80b is the same as 16 times 5. 80 is the same as 16 times 5, then that is times b. Then we have, this is plus. Now the 20 here, 20 is the same as 4 times 5. 4 times 5, then times a squared times b. You realize that the numbers we've chosen here, 16 and 5, 16 is a perfect square. So we can easily find the square root of this, which is 4. Even here, 4 times 5 is giving us 24 is a perfect square. So we only choose factors where one of them is a perfect square. So after that step, this becomes 4a squared times the square root of 16 times the square root of 5 times the square root of b. That is plus the square root of 4 times the square root of 5 times the square root of a squared times the square root of b. So our next step here is going to be 4a squared times 16, root of 16 is 4, so it's 4 times the square root of 5 times the square root of b. Then we have plus square root of 4, which is 2, times the square root of 5. Now the square root of a squared, this goes with that, you remain with a, times a, then times the square root of b. So this, simplifying this further, is going to give us 4 times 4, giving us 16 a squared. So it's going to be 16 a squared times the square root of 5b plus, this is going to become 2 times a, which is 2a, times the square root of 5b. Okay, now this square is not supposed to be here. From this point, this is not supposed to be right there. It's an error. So we have 16a times root of 5b plus 2a root of 5b. So 16a plus 2a is going to be 18a times the square root of 5b. And that's the simplification of that brings us to the end of this video. Thanks for tuning in. For more of these videos, I encourage you to subscribe to this channel. Up next, we shall be doing more of these surds. For Kisembo Academy, this is Arnold Rangakuramia.